Hi, we are continuing with the parts of fermenter. The next part of the aeration agitation system is sterile glands and bearings. Sterile glands and bearing is to assure the entry of the shaft of the agitator into the fermenter. So inside the fermenter we have the microorganisms and the fermentation media, and we need to ensure two different things by using sterile glands and bearings. First thing is the smooth entry of the stirrer shaft. The motor of the agitator is placed outside the fermenter and shaft is coming inside. So it should be like the rotation of the shaft should be assured when the shaft is entering into the fermenter. Secondly, there should be no chance of contamination and containment things should be maintained. So through this sterile glands, no microorganism should enter the fermenter, plus no microorganism from the fermenter should go out. So it's a special type of setup is needed to ensure that the containment and the chance of contamination is avoided at the point of shaft entry, which is assured by sterile glands and bearings. It will help to maintain aseptic conditions for long run. Stirrer shaft, typically in all our figures we represent that stirrer shaft is entering from top, but that is not necessary. The stirrer shaft can enter from sides, bottom, or any places, any side of the fermenter, but typically it represented like it is in the top. And if the length of the shaft is less, the speed will be high, the power of the shaft will be high, and for ensuring the aseptic entry of the shaft of the agitator into the fermenter, there are four different types of setup is available. First one is stuffing box, secondly simple bush, mechanical seal, and a magnetic drive. These are the four types of stirrer seals available. So I'm just going through the few of the figures. This is what we call the stuffing box. It's also called a packed gland seal. Here we have something called stuffing bush, which is actually helping to maintaining the aseptic entry of the shaft. This one is the shaft. This is the whole setup, which is made to ensure the aseptic entry of the shaft into the fermenter. Here we have the simple bush. We have placed a few bushes here, like this is the stirrer shaft, and this bushes will be pushed against each other so that the entry of the shaft will be possible. This is the mechanical seal. Mechanical seal, we have some spring load here, so which is adjusted with the power of the shaft, and this setup the shaft will be able to rotate freely. At the same time the aseptic conditions will be maintained and there is no chance of leakage in mechanical seal. Finally, we have the magnetic drive. This one we have in our laboratories. So suppose this top beaker is our fermenter, and we will put one magnet over here, and we place this whole setup on top of a magnetic stirrer, and inside the magnetic stirrer we have another magnet. As the magnet in the we can actually mechanically rotate the magnet in the magnetic drive using electric power. So once we rotate the magnet in the magnet stirrer, the magnetic probe in the fermenter will also rotate, so which is called magnetic drive. In this case there is no need of stirrer seals or anything. It's just a magnetic thing, but the disadvantage is that it can be used only with a limited number of fermenters, and in case of less low volume laboratory scale fermenters, this can be used, but it is extensively used for animal tissue culture and sometimes plant tissue culture, because in this case there is no need of sealing or something like that, and this plant and animal tissue culture need only less agitation when compared to microbial cultures. So this is an image video of how the magnetic stirrer is working. Here is a beaker, it can be a fermenter, and it is placed on top of a stirrer, and this magnet is rotating because inside the stirrer we have another magnet is rotating. One thing you should look at is that the vortex. When there is a agitation by using magnetic stirrer or any other impellers, there is a chance of vortexing. This vortex, which is not good because it will reduce the working volume. So what we do, we will, in this video you can see, we are inserting small bars, the 4 different bars into the beaker. Two things you can actually see. First one is the, let me show you. In this time the particles are rotating only in circular motion, but once we insert these bars, actually vortexing is completely avoided and the mixing has become more uniform. So in the most of the fermenters we use things like this. This is called baffles. Baffles serve two main purposes. One is to assure proper mixing. Secondly, to prevent vortexing. Here you can see, after inserting this thing, there is no vortex in the system and there is uniform mixing of the particles in the system. So the third component of aeration agitation system is baffles. So baffles are like this, bars like this. It is placed against the walls of the fermenter. It will prevent vortexing, it will improve aeration, and typically we are using 4 different baffles, equally spaced. They are actually metal strips in the fermenters, which is has a diameter of 1/10 of the fermenter. They are attached to the walls. Okay, and the advantage is that whenever you are using whatever type of embellers we are using, most of them leads to the vortexing and swirling motion of the particles. There is the uniform motion is not there. This vortexing is not good because it leads to the increased working volume. Okay, it may lead to the contamination or something like that. So what we will use baffles. So here we don't have baffles in this system, we have baffles. So we have the axial circulation throughout the medium, and further there are sub circulations in the top view. You can see small circulations, which is good. The proper mixing will be assured by the baffles. Thank you so much.